Okay, let's give you guys some more practice. So use trigonometric substitution to integrate this definite integral from square root of 2 to 2. So press pause and have a go. Okay, so to integrate this, your eyes will zoom into this complicated square root thing, and then create your right angle triangle in such a way. So create your right angle triangle in such a way that this is true. You see, if you make this to be, if you make the hypotenuse to be x, the adjacent to be 1, then the opposite will have no choice but to be the square root of x squared minus 1. So in order for you to integrate that, so in order for you to integrate this, you're right to zoom into this bit here, create your triangle in such a way that this statement is true. So if you make the hypotenuse to be x, the adjacent to be 1, then the opposite will have no choice but to be this. So once you've got your right angle triangle, you can then jump to here, because if you look at your right angle triangle, secant of theta, which is this here, so this is your secant equals equals hypotenuse over the adjacent. Well, this thing here is exactly the same as this. So once you've got this, differentiate both sides. So this would then become this, and then this will then become this. So dx equals this thing here. So we can then put the dx into here. Okay, and now look back at your right angle triangle. Tan theta will be opposite over the adjacent. So this complicated bit here. So this complicated bit here is really tan theta. So we can put tan theta into here. And then now we still need to sort this out. Well, x to the power 3. If you look back to this, currently x equals this thing here. So if you want x to the power 3, then cube both sides. So we can now put this into here. Then this whole thing here will then become this. Then this whole thing here will then become this. So, but the thing is, we still need to sort out the interval here. Okay. So we still need to figure out this, and we still need to figure out this, because if you look at this here on the left hand side, we are integrating with respect to x. So what that means is we are integrating from x being from square root of 2 all the way to 2. But then once we've made this substitution, we need to figure out this and this. So if you look on the left hand side, we are living in the x world. We are integrating x from the square root of 2 to 2. But once we are here. Once we've made our substitution, we are now in the d theta realm. So we still need we need to translate this, and we need to translate this. So hang on. So we are currently in this world here. Make our substitution. That will then take us into the d theta realm. We need to figure out this. We need to figure out this. So in this realm here, we are integrating from the square root of 2. So we are integrating from the square root of 2. We are integrating from x being from the square root of 2 all the way to 2. So we need to figure out this theta here, and we also need to figure out this theta here. So we need to figure out this, which also represents this. We need to figure out this, which is this bit here. So if you look at this here, we need to know secant of what will give us the square root of 2. So hopefully you would have seen this before. This is just a table of all the common values here. If you look at secant, so this is just a table of all the common values. So maybe you should already know this. We are really looking for some secant of what will give us square root of 2. Well, if you secant pi over 4, it will give you the square root of 2. So when you look back to this, this here should be pi over 4. So remember, we are integrating from square root of 2 all the way to 2. So we need to figure out this theta here, which happens to be this. So when you secant theta, it will give you square root of 2. But now we still need to figure out this. Secant of what will give us 2. So if you look at a table of all the common values here, secant of what will give us 2. Secant of what will give us 2. Well, 2 is here. So if you secant pi over 3, it will give you 2. Okay, so hang on. So if you secant pi over 3, if you secant pi over 3, it will give you 2. So really, the pi over 4, this will be pi over 3. So to translate this will then give us pi over 4 here, and then pi over 3. So when you're in the dx realm, you're integrating from square root of 2 all the way to 2. But once you've made this substitution, you are now living in the d theta world. So in the d theta world, you need to integrate from pi over 4 to pi over 3. Okay, so that will then take us to here. That will then take us to here. Hang on. That will then take us to here. So we've just sorted this out, and we've just sorted this out. Earlier we've already done this. So now cancel this and then tidy this up. It will then give you this. Well, 1 over secant squared will then would be the equivalent of cos squared of theta. So now it's just a matter of integrating this. Integrating that will then give you, well, rewrite this. So to integrate this, rewrite it as this. And you should already know this. Okay, so from here, use this to turn this into this. So now integrate this. It will then give you this. Integrate this. It will then give you this thing here. Okay, so now we need to put this into here and into here, which will then give you this. And then take away. Now put this into here and into here. That will then give you this. Okay. Yes, somehow convince yourself. Well, from here it will then take you to here, and then tidy this up, and the overall answer will be this. Okay.